everyone. In this session, we are going to learn about PIC microcontroller 16F877 CCP module compare mode of operation. Learning outcomes. At the end of this session, students will be able to describe the compare mode of operation of CCP module and its features for PIC microcontroller 16F877A and describe the compare mode operation of block diagram, internal functional block diagram of PIC microcontroller. So these are the contents of today's session. The compare mode of CCP module is useful for performing any external operation events at desired time interval, regular time interval, using the interrupt signal or pulsed signal. So that is generated on the microcontroller device output pin. When timer 1 value with predetermined comparison value, so timer 1 is used to support the working of CCP module for compare mode of operation. So when timer 1 value equals with predetermined, pre-programmed comparison value in special function register of CCP module, action takes place for some external events or operations. An action on output pin can be defined as or programmed as in 3 different ways. So output of CCP module can be driven high, can be made logic 1, or it can be made logic 0, driven low, or it can be remain unchanged as it is, remains as unchanged. Now let us discuss capture mode of operation for CCP module. In PIC microcontroller, there are 2 CCP modules, CCP1 and CCP2. So these 2 modules are identical in their operation. So in today's session, we are going to discuss with reference to CCP1 module capture mode of operation. Compare mode of operation. 16-bit value is constantly compared with timer 1 register pair value TMR1H and TMR1L. When a match occurs or value equals, an action takes place. When value in CCP R1H register and CCP R1L register becomes equal to timer 1 register TMR1L and TMR1H register, action takes place or action is generated, produced on the output pin of CCP module. So that is RC2/CCP1 of a PIC microcontroller 16F877. So at the same time, the interrupt flag bit is generated in CCP1IF interrupt flag at bit position 2 in PIR1 register, peripheral interrupt register 1. For generate software interrupt mode, CCP pin is not affected. So when it is CCP module is programmed for software interrupt generation mode, the signal on output pin of CCP module is not changing, not affected. Only bit CCP1IF, that is set in PIR1 register at bit position 2. For special event trigger mode, if CCP module is programmed in compare mode operation for special event trigger mode, an internal hardware trigger signal is generated and may be used to generate or to perform an action. Now we are going to discuss how to configure a CCP1 module for compare mode of operation. So to work in a compare mode of operation, the pin CCP pin should be configured as output. In compare mode, the RC2/CCP1 pin, so that belongs to CCP1 module, should be configured as output by clearing the data direction control register tree C that concerned with port C, because CCP1 output pin is multiplexed with port C pin. So at bit position 2, a bit is cleared in tree C register, so that CCP1 pin will act as a output pin. CCP1 module takes a support of timer 1 for compare mode of operation. So timer 1 mode selection. So timer 1 should be programmed, configured to operate as a timer. Timer 1 must be running in a timer mode or a synchronized counter mode. For the CCP module to use the compare feature, if CCP module in compare mode, software interrupt mode is selected, it causes a CCP interrupt. It causes a CCP interrupt if it is enabled in PI1 register. So to generate an interrupt from CCP module, the interrupt should be enabled in peripheral interrupt register 1, PI1 register for CCP module 1 for CCP1 IF. Now this figure shows a bit format for control register for CCP module, CCP1 con and CCP2 con. The bit format is common for both CCP1 module and CCP2 module. So using this bit format, we can generate a control word or command word that should be written in CCP1 con register to program a CCP module to in different modes of compare mode of operation. The least significant bits named as CCP1 YAM0, YAM1, CCP1 YAM2, CCP1 YAM3. So these 4 least significant 4 bits are used to select one of the 4 mode of operation, like 1000, that is compare mode, set output on match, bit is set. Then 1001, compare mode, clear output on match. So first combination is used to set the output and second combination is used to clear the output whenever event occurs, whenever event takes place. So 1010, that is compare mode, generate a software interrupt on a match. So for 1010, the output pin, status of output pin of CCP module will not change, only the interrupt is generated. So whenever match occurs, the timer 1 value equals with CCP R1 register. CCP1 X1 IF bit is set in CCP1 pin is unaffected whenever a software interrupt mode is selected. For 1011, a compare mode, trigger a special event. So this 1011 is used for special event trigger mode, generate a special event trigger, internal hardware signal. So that signal is internally used to reset timer 1. In case of CCP1, it resets only timer 1, and for CCP2 module, special event trigger signal resets timer 1, as well as it starts analog to digital conversion automatically. The special event trigger output of CCP1 resets timer 1 register pair, TMR1H and TMR1L, collectively a 16-bit register. So this makes CCP R1 register to act as a 16-bit programmable period register for timer 1. The special event trigger output of CCP2 resets a timer 1 register pair as well as starts analog to digital conversion if analog to digital conversion module is enabled. So this figure shows a block diagram, functional block diagram for compare mode of operation for CCP module. So whenever the value programmed in CCP register equals with timer register, the signal is generated and provided on RC2/CCP1 pin. Either it becomes high or low, or it remains as it is depending upon mode of operation selected. These are the references. Thanks.